Now, skill check B on page 317 gives you an opportunity to practice some more problems where you are finding the percent by using this proportion. So let's look at example 3. What if we're looking for the whole? Example 3 says, what is the original price of a sweater that's on sale for $17? So the sale price is $17, and it's marked 60% off the original price. Okay? So what is the original price? That's what I'm looking for. The original price. All right? So I know that the sale price is the part and the original price is the whole. Am I going to put 60% here? No, because it was 60% off. So that means they took 60% off of the entire price, which was $100. So that means $17 what I paid 40% of the original cost. So I'm going to put 40 here as my percent. When I do cross products, 40x equals 1700, and then I divide both sides by 40, and I find that x equals 42.5. So the original price must have been $42.50. And then when 60% came off of that or was deducted from that, it left a sale price of $17, which is 40% of the original price. Okay? So let's talk about finding the complement of an event. When I find the complement of an event, that means the likelihood that an event will happen. Okay? So the complement of that means I'm going to say the likelihood this is going to happen and subtract it from 1 to find out the likelihood that it's not going to happen. Kind of what we just did here with the price, right? We took the original price and we subtracted this to find the complement, which was the percentage of the original price that we actually paid. So example 4 says there's 140 7th graders at Valley Christian School. If 85% wore school colors on Spirit Day, how many did not wear school colors that day? Okay, I can do this problem 2 ways. There's 140 students. 85% are wearing school colors. Okay, I can work with these 2 numbers and get an answer and say this many kids wore school colors, so I'll subtract it from the total to find out how many didn't wear school colors. Or I can also work with the percent and say if 85% wore school colors, that means 15% did not wear school colors. And that's what it's asking me to find. So that's the complement. Complement's just a word we use in math. We use it in geometry to mean everything that's not part of this group, but it's part of the total group. For instance, here's our Venn diagram, right? I've got kids that did wear school colors, kids that did not wear school colors. The box represents all my students. Let's say SC for school colors, and then we'll just put a slash, right? So the ones that did not is a complement of the ones that did, and the ones that did is the complement of the ones that did not. If that kind of makes a little bit more sense about what we mean with the word complement. So I'm going to work my problem with the 15%. I'm going to say how many students represent 15% of the whole. Cross products gives me 100x equals, let's see, 2100. And then I'll divide both sides by 100 and see that 21 students did not wear school colors. Now let's look at the other way we could work this. We could use these numbers, 140 and 85. We'll use cross products. 100x equals 140 times 85. And divide both sides by 100. And we'll see that x equals 119. I just have to remember when I get to the end of this problem, 119 students did not wear school colors. 119 students did wear school colors. But if I choose to solve my problem with the information, the numbers that are given to me in the word problem, then I have to remember once I find this answer, I've got to take that answer and subtract it from the whole to get an answer that realistically, accurately answers the question I'm being asked. Because the question I was asked was how many did not wear school colors. So two ways I can do it. I can work it with 140 and 85, get my answer, and subtract those students from the total student body to find how many did not wear school colors. Or I can say if 85% wore school colors, 100% minus 85% means 15% did not wear school colors, and I can work my proportion with 15%, and the answer that I get will be the number of students who did not wear school colors. Okay? And both of these methods are listed on page 318 in your textbook. And then Skill Check C gives you an opportunity to practice finding the missing number. So let's look at what your assignment might be like today. Let's see. Let's do one through 17 odd. And then let's do 19 through 22 all. (24 through 30 even). And your cumulative review. Okay, and before we close out this video, let's talk about different scenarios where we might need to use this complement information to solve a problem that has percents in it. One is going to be when we're talking about the price of something, sale price and the discount price. When we're talking about a merchant who's purchased something he's going to resell and he's going to mark it up, or when we talk about a merchant who has something he's going to put on sale and he's going to discount it or reduce the price. We need this complement information when we work those kind of problems. Also, anytime we're working problems with data, such as number of students and percent that did this or did that, percent that like vanilla, like chocolate, we have to read our questions carefully because sometimes the question may say how many did not do such and such. And when I see the word not in there, I know they're looking for the complement of something. So I need to be careful that I don't just simply work a problem with the numbers I see in front of me, and then because I've got an answer, I write that down and say this is the answer to the question. Because if the question has the word not in it, the number I come up with might not actually answer the question. It might answer another question like how many students did wear school colors? And then I use that information to answer the question how many did not wear school colors? Okay, so that's something that I have to keep in mind when I'm working problems, word problems that involve percent. When might I need to use this complement information to make sure I'm finding the correct answer to answer the question that I'm actually being asked to answer?